Okay, almost at item 2. It is pre-calc. This is 10.7, and this one is on. I think I kind of vaguely remember. I moved this over from my old slides, and you can see I used to do it on Word for a PowerPoint. Anyway. Here we go. So this is 10.7. This is converting from polar coordinates to rectangular and vice versa, and how to change a polar equation to rectangular and a rectangular equation to polar. All right, well, let's go ahead and start with, first of all, if you know r and theta, right? So it's an ordered pair. If you have polar coordinates on the polar plane, they're as an ordered pair r and theta. And if it's on the rectangular coordinate plane, then you have an x and y coordinate. And suppose you have r and theta and you want x and y. Well, here it is. What you're going to do is you're going to do x. The x value is r cosine of theta, right? Makes sense. That's the, if we have a picture. And this is r, and this is theta. Oh, no, what am I doing here? New share is what I want. Okay. So let's think about this, right? If this is like the polar plane, and this is like r is going out like this pole right here. So this would be, r, and this would be theta, right? But what we want is we want the x and the y coordinates for this. And so we can see that x would be equal to r cosine of theta. Let's try it. What is cosine of theta? Cosine is x. It'd be the adjacent over hypotenuse, it'd be x over r, and the r's would cancel, you get x equals x. And conversely, if you have y equals r sine of theta, that makes sense for this one, because what's the sine of theta? Sin is opposite over hypotenuse, y over r. And if I put a y over r in for sine, the r's cancel, you get y equals y. So there it is. If you know r and theta, all you have to do is plug in r and theta here, in each of these you have x and y. Okay, now let me see if I've got an example of that, or maybe I do both directions first and then do, nope, I don't. So it says here convert. Okay, the second one, okay, we'll talk about it. So the first one is, I gotta go over and do that, is -2, -5 pi 6. And let me go ahead and pause it and get the lights back. Okay, we have a couple things, so I kind of forgot where I was. Here we go. I need to switch over, don't I? Let me write them both down. The other one is, so I don't have to go back and forth, is 3, 270. That's the one I kind of want to talk about. The one's in radians, one's in degrees, big deal. Go new share here. All right, so, okay. So let's talk about x is equal to -2 times the cosine of -5 pi over 6, no calculator. Y equals -2 times the sine of -5 pi over 6. Now, -5 pi over 6 means we're going to go clockwise 150 degrees, which is the same thing as 210, right? 210. So it's going to be equal to -2, and this is going to be -√3 over 2. -√3 over 2. And we got a negative times a negative is a positive, and the 2's cancel. So this is just going to be √3. Yep, sorry, I had to think about it for a second. So I was thinking if I'm in the third quadrant and then I have to go negative, that's going to put me in the first quadrant. Makes sense. And then this one here is going to be -2 times the sine of 210, right? It's actually -150. That's the same thing as 210 coterminal. So that's going to be -1/2. And -2 times -1/2 is 1. So it's the ordered pair √3, 1. Okay. Now this one here, you should be able to get it. If I go 3 in the 270 degree direction, that's just straight down. That's that's 0, -3. That's 0, -3, right? So you can just I don't need to even write anything out, but let's do it. Let's write it. This would be, even though you shouldn't have to, it's going to be 3 times the cosine of 270. So y equals 3 times the sine of 270. What's the cosine of 270? It's 0. 3 times 0 is 0. What is the sine of 270? It's -1. 3 times -1 is -3. So 0, -3. Of course, right? We know that if you go 3 in the 270-degree direction, that's straight down 3. All right. So that's that. That's how you take something that's in polar form, a polar ordered pair, and put it to rectangular. Now let's go the other way. Let's see how we do that. Let me hit pause or even stop would be worse. Good. That's what I want. Okay. So converting from rectangular to polar now. So this is if you know x and y and you want r and theta. Well, first of all, and it's not too hard, r is always 1, but it will be in this case when you're converting. R, because what it's going to do is if it were, you could, remember there's multiple ways to depict. That's actually in the year 2022, one of the test questions. Like if I say, here's an r theta value, give me 3 other ways to depict it. Where theta is between -360 and +360, or between -2 pi and +2 pi. And we did that as an example during flex, but I'm going to do it again when I teach this lesson. Anyway, here we go. So, so a coordinate could be described with an r value that's negative, but there are other ways to describe it with an r value that's positive. And that's what I'm going to do here. So r is always equal to the square root. Remember, if you take the square root of a number, it's always going to be positive. So unless it's a negative number under the radical, and if you square 2 numbers, right? If you square a number, if it's positive, it's going to be positive. And if it's negative, it's still going to be positive. So we're going to have a positive number under that radical. So r will always be positive for our case when we're converting. All right. So r is equal to the square root of, if you know x and y, right? And you want r and theta, r is going to be equal to x squared, square root of x squared plus y squared. It is the Pythagorean theorem after all. I could show, here's that picture again. I'll show you. Let's do it. Okay, so here's that picture again. And so it makes sense, right? Before we had r and theta, and we had to convert that to x and y. And this is the other way around. This time we know x and y, and we want to know r. Well, what is r? It's the Pythagorean theorem. It's, put a right angle symbol in. It's leg squared plus leg squared equals hypotenuse squared. And what is theta? It's opposite over adjacent tangent. Tangent of theta is equal to y over x, which means theta, the measure of that angle theta, would be the arctangent of y over x, which is what we have there. That's what's shown in that, on that slide. So that's where those come from. Now, what you have to be careful of, it's the only thing you got to be careful, but it says, but use some trig logic. Yep. Good job, Freud. Thank you. You're welcome. So when you get the answer in your calculator, when you get it, you can't just go, oh, there's the answer and write it out. You got to think about what quadrant it's really in. And if x is negative, meaning the second or third quadrant, the angle falls in the second or third quadrant, then you have to add 180 to that number that's in your calculator. So it's a little tricky, okay? Here we go, let's do it. Suppose I have the ordered pair 2, -4, and I'll just write them both out. And the other one is -3, 1, and we want to convert that to an r theta value. Keep doing it over and over. All right, there we go. Let's do this one first. Move this over a little bit. Okay, so r would be the square root of 2 squared plus -4 squared, which would be equal to the square root of 4 plus 16, which is the square root of 20, which is the square root of 4 times the square root of 5, which is 2√5. So there's my r value, 2√5. Now, theta is going to be equal to the arctangent of y over x. Now, I don't know what that is because it's not a unit circle value. So I'm going to go ahead and get that on my calculator. Arctangent of -4 over 2 is -2. You could put -4 divided by 2, of course, but I'm just going to put -2. and I'm getting negative 63.43. And let's think about it. If I go in the positive x, negative y, I'm in the fourth quadrant, and negative 63.43 is. It is. However, remember the convention is that you always want to give this angle. I'm not going to mark it wrong if you put negative 63.43, but the convention is you want to write this as an angle between 0 and 360. So let's get the coterminal angle to it by adding 360. I'll do that right now. And I'm going to write the more conventional way to write this, which is 296.6, about to the nearest tenth. Well, remember, it's got to be listed as an ordered pair. It's r, which is 2 root 5, comma, 296.6 degrees. Okay, now let's do this one. This is negative 3,1. So r is going to be equal, let me draw a line here. It's going to be r is the square root of negative 3 squared plus 1 squared, which is 9 plus 1, which is 10. So square root of 10, square root of 10 can't be reduced. That's that. Theta is the arctangent of y over x, would be 1 over negative 3. And again, that's not a unit circle value. It's terrible looking negative 3. That's not a unit circle value, so I'm going to have to get a calculator and do it. It's going to be the arctangent of negative 1/3. And I'm getting negative 18 degrees. And now let's think about it. Negative 18 degrees is in the fourth quadrant, which would be positive x, negative y. Uh-oh, this is negative x, positive y. It's in the second quadrant. I must add 180 to this. That's not the right angle. I needed my calculator. I needed it as a tool, but I need to have some smarts about trig to know that it's, it gave me the principal value and I didn't want the one that wasn't the principal value. So I have to add 180. And I'm getting about 161.6 degrees. And again, they must be listed as an ordered pair. So this would be root 10, comma, 161.6 degrees. And of course, these could be in radians too, right? Could be. All righty. Now we're going to look at equations. And I'm going to say the ones in the homework are quite a bit harder, kind of like what I do. Usually I give easy ones as examples. And in the homework, you're going to want to watch that other video to see some harder ones. Although what I give you on the test in the year 2022 is not going to be that hard because I already know, because I just made a test. Here we go. There it is. All right, so write the polar equation r equals -3 in rectangular form. Well, that's a circle. It should look like it's in the form of a circle, right? And this is a circle whose center is at the pole, and the radius is 3. Write it. Excuse me, let me write it. This is r equals -3. This one's so simple. My goodness. All right, here we go. So I was going to say square, but since I guess I could do that first. Let's substitute back in. What is r in the rectangular world? R in the rectangular world is the square root of x squared plus y squared equals 3. And then you could square both sides. This would be x squared plus y squared equals 9. And there it is, right? The center is at the origin, 0, 0, and the radius is 3. Well, this one's the center's at the pole and the radius is 3. So yeah, I can see it's the same thing. But that's what it looks like. That's what that equation looks like in rectangular form. And now let's go the other direction. And again, you're going to want to watch the video where I do some of the harder ones. So that's obviously pretty easy. I don't know how many times I'm going to mess that up before I get it right. Luckily, I'm not hitting stop. Okay, we write this. So this one's in rectangular form, and we want to go to polar. It's going to be x squared plus, yeah, this is definitely harder. Y minus 1 squared equals 1. Here we go. I did it again. Crazy. All right, here we go. So I'm going to substitute in for, just like I did here, right? I substituted for r, the square root of x squared plus y squared. That's what r equals. If it was theta, right, I want to substitute in what theta is. And this time I'm going to substitute in the polar world what x is, and in the polar world what y is. So this would be r cosine of theta squared plus r sine theta minus 1 squared equals 1. All right, so what do? You square each of these, right? If you have a times b squared, you square a and you square b. So it's going to be r squared cosine squared of theta plus, that's going to be, okay, that I'm going to expand, right? That's a binomial, so I'll use binomial expansion here. So this is going to be square the r, square the sine. It's going to be r squared sine squared theta. And that's going to be minus 2r sine theta plus 1 equals 1. Well, the first thing I want to do is probably subtract those 1s from each side, okay? And then next, what I'm going to do is I'm going to factor out an r squared out of both of those terms. So this would be r squared times, okay, cosine squared of theta plus sine squared of theta minus 2r sine theta equals 0, right? Because those 1s can't. Now, sine squared, that's a Pythagorean identity. It's our most common one. It's sine squared plus cosine squared is 1. So 1 times r squared is just r squared. Let me write it. R squared minus 2r sine of theta equals 0. And now we can factor out an r out of each of these. R times r minus 2 sine of theta equals 0. And, oops, in that bracket. And then I can divide both sides by r. And I get r minus 2 sine of theta equals 0. And then I can add a 2 sine of theta, and we get r equals 2 sine of theta. Now, we haven't talked about in class yet how to graph these, but we will. For that, in the year 2022, I just want to make that clear, where it's an optional 20-point test if you want to graph polar equations. But let's do it. I want to get Desmos and do it without explaining why it is. I just want to show you. If you look at this in rectangular form, you can see it is a circle whose center is at 0, 1, and the radius is 1. 0, 1, so 1 up from the origin, and radius is 1, right? Well, let me hit pause and bring Desmos up and show you that that would be the same thing. Again, without any explanation, admittedly. Let me hit pause here. Okay, so I did it I did r equals 2 sine theta, so I'm graphing a polar equation here. And you can see, yeah, it comes out to be the same if I do r equals 2 in the polar world. It comes out to be a circle whose center is at 1 above the origin and the radius is 1. So I converted it from rectangular and I turned it into a polar equation. I went the other way. All right, now that's what you're gonna have to do in the homework. Now it's a matter of practice, right? Just doing a bunch of different ones. I'll make a video eventually of those kind of homework problems, of which there's a lot. Now let me show you one more thing. Did it again, over and over. It says here COVID reduced. Well, in the year 2022, we're back in the classroom. We're not going to consider it to be COVID reduced. So I want you to go to, I'm not going to go to Google Classroom and look, but don't use this. Do not use this as your guide for the homework, please. Look on Google Classroom and see what the actual homework assignment is. You can see it's a lot of problems, right? Although it was going, you go multiples of 4 here. Anyway, remember, okay, I'm going to stop talking. I'm going to stop talking and cut it off here. All righty, catch you in class. Bye-bye.